And we are back, Lee.
Hey, yeah, we in our last video we were talking about this little seam, and in a way it is a sampling thing, and I was starting to think it was a floating point error, and I realized no, that's the thing we need to fix next. What is happening is if you look, we're missing a gap at very specific spots in our terrain. If you look
Well,
on,
you can see a pattern right off the bat. Every other one, starting with the point you're on, is connected.
yep, and then every other one is not. And the ones that aren't connected are those points that we had brought in and forced short inside of our grid when we first constructed it. I believe we have an image of that in Photoshop, do we not?
I do believe so.
Right, here it is. So if you remember when we constructed this guy, these points here and here, here, and here were initially out by half the distance at each one, and we forced them in.
Right.
If you look at this display, and then we go back into Unity, those points are the ones that we forced in.
Yeah, I mean, well, you can tell they're the straight lines as
Yep,
opposed to the diagonals that are running in, which you can see right back again over here. Straight lines instead of the diagonals that are running in.
right. And then if we go back to Unity, and if I rotate this close enough, we can see a pattern, which is these things are pretty much set up at an altitude that is linear to the point where they were before. So what's happening is we've got this point and it's leading up to the point where it would have been if we continued the sample in that direction. So what we have to do is force these back in and sample them separately. And that's what we're going to do now.
Okay.
So we can go ahead and stop that, jump back over in the code. Now, where we're going to fix this is inside of Terrain Patch. We scroll down to our create grid. We had implemented two different cases. We had one where if Z was an even number, we sampled one way, which was here, and then or we built our vertice one way and we're sampling one way here. But we have a different case that says if we're on an odd row on Z, that we have to force in the points on the ends and squish them in to keep them all nice and aligned so they're square. And that's what we're doing here, but we're not taking that into consideration when we're sampling our height information. And if you look, we're just pulling X. We're not using this position X at all.
Yeah, we're pulling X from position itself instead of POSX.
Right. So what we're getting is some inaccuracies on our sampling information. So we have to set up the ability to sample the correct information. So to do this, we're going to need a condition. That condition is going to be checking the position in X and determining whether or not it is 0, which means are we on the left side of our grid, or if position X is equal to our size minus 1. This is the subtract from the extra vertex that we add in, times our spacing. So what we're going to do is we're going to check to see if the vertex we're testing is either on the left or the right-hand side. If it is, then we can use this information here and Shift N, copy that out, set that to 0. Set 0F just so I get height information. And then I'm going to set height equal to this, but instead of X, I want to use position X because I want to be able to get the information from our adjusted position X, not if it was continuing off into that position as if we
Right.
never had jammed it back in.
And man, you should have called me a second ago when I said not X but position X. You were like, yeah. And the answer is actually no. It's really POSX and
Okay,
X that we were talking about.
yeah, pause X.
Yeah,
Now I see what you're saying.
I was just staring at position.x. I don't know.
Well, see, I read this as position X. It was just me
Yeah.
reading. All right, now, oh, Nelson's got this adjusted differently. All right, now this is if our POSX has been adjusted. We're sampling this way. We need to sample slightly differently if we're sampling anything else on that row. Now, if I go back to Photoshop, which would help if I was inside of your windows
Yeah, probably so.
rather than mine. Now, if you remember, every other row is halfway in between positions. So if we were to look at this as a regular height map, this would be 0, 0, 0, 1, 0, 2. This spot up here would be 0. Did I say 0? Yeah,
Yeah.
so this is 0, 1, 1, 0,
Thank you.
2, 0. And this would be 0, 0, 1,
Right.
0, or now I'm getting confused. This should have been 1, 1. It should have been over here, but we've moved it halfway in between.
Right, it's 0.51.
Right. So what we have to do is we need to calculate what this altitude is going to be. So,
Altitude or position?
well, it's height. We know it's
Okay,
position.
I see what you're saying. I see what you're saying.
So we know that this, if we were to plot it, would be at zero point 0.5 comma 1
Hmm.
because it's 1 up, but it's only half over.
Exactly.
But because we're sampling on a grid, we don't know what that is. And we can't get a half position. So we have to sample the point just to the left of it and the point just to the right of it, and then get the interpolation in between the two.
Okay.
So that's what we're going to do. And if I go ahead and get back into code, to do this, we're going to set up a var. We're going to call the first one H1 for height 1. And we're going to take this line of code and copy it and paste it down here. Now we need to change it. And the reason we need to change it is we know that the POSX has been adjusted for the spaces at the edge. We don't need that. We need the X value itself. We still need to know if it's spacing or by its spacing. We need to multiply it by its spacing, but we need to subtract 1 unit of spacing away from that because we're trying to get to the point to the left of it. So we know X, and back into Photoshop, and I'm still selecting the wrong menu bar. So if I go back here, we know that if this point would have normally been here. So we're subtracting 1 unit of spacing backwards. So we're getting this point here for our height 1.
Hmm.
So that's why we're subtracting 1 unit of spacing. And we're using a unit of spacing because we've made spacing variable, so we have the flexibility of adjusting the density of our grid. So we're going to subtract 1 unit of spacing, then we're going to subtract our offset, and then add position X to that. That gives us our H1. We also need an H2, which is going to be the point where it would have been before we shifted it off to the side. So again, I can paste in the code from before. Instead of POSX, we're just going to take X and we're just going to take the spacing. We're not going to subtract 1 unit from it.
Right.
Now, the last part of this is calculating the height. So we can take our height, and we can do this a couple of different ways. We could do H1 plus H2 divided by 2, and I could put these in brackets. So I do the addition before I do the subtraction. So we could do it that way. We can also use the mathf function called lerp, and we can pass in h1, h2, and tell it 0.5 to go halfway between, and that'll lerp in between the two of them. I'm just going to leave that one. It does work. Not much of a performance hit on this anyways, and it's only done at the load time of the level. So it's not something that we're running all the time. And this is the technique that we're going to be using in the real sampling part of it, because we're not always going to be
Right.
exactly halfway between the point. But I wanted to show this, and I wanted people to get used to thinking about getting an interpolation of a point between two other points using a lerp method.
Hmm.
So I just wanted to introduce that part to you guys now. So if we build that out and we go ahead and run Unity, if you want to give that a shot.
Oh yeah. Oh, I'm not seeing seams. Well, let's just jump over here.
Now you can see a seam.
Yeah, I let me rephrase that. I'm not seeing tears in the
There's no
seam.
tears in it.
That's what I meant.
Our seaming is done for free. You can notice a difference in the seam, and that's because the normals are not being calculated across the terrain patches.
Exactly.
That is a more advanced topic and something that we will look at how to solve when we start getting into texturing our terrain. But for now, it doesn't affect the functionality, so we're not going to bother with it. But if you bring up multiple patches like you have now, you can see that every point along all the edges are matched up. Essentially, we've just got terrain patch seaming for free.
Very nice, and nothing wrong with free in the world of programming.
Right.
All right, and da 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 da. And I can run around the UK. Now I'm taking a swim,
Yeah.
and I'm back up out to an
But it
island.
but as you run around, it definitely does have some issues. It doesn't really look like a real terrain.
No, well, could be some far off planet. And these are like ice shards or something.
It's the world of the Lilliputians, and you're gullible.
Okay,
So,
so
but in the next video, what we're going to take a look at is how we can scale this up to look at something that looks much more like a landscape. It
okay.
still has some issues, and what we're going to do is jump back into Photoshop
Hmm.
and address some of those issues for our base map. It's not our final result by a long shot, but it's pre-processing our base map texture to get it in place for when we start putting in the noise super sampling.
Awesome. Okay, then with that, that is going to wrap up this video. Thanks a lot.